Whoa there, space trekkers, it's me again, Cosmo Croc, your interstellar snacker and cosmic tour guide. Today we're heading off the starry path to explore one of the universe's most curious mysteries, rogue planets, those wild wanderers of space that drift all alone without a star to call home. Unlike Earth, which happily orbits the sun, rogue planets just roam the galaxy by themselves. No cozy starlight, no fixed path, no planetary neighbors. They're like space drifters, lonely, elusive, and totally fascinating. We've got tons to uncover, from how they're born, to what they're made of, to how we even find them. So strap in, space cadets. It's going to be a wild ride into the deep dark. What are rogue planets? Let's start with the basics. What is a rogue planet? Also called freeloading planets or interstellar planets, rogue planets are planetary mass objects that don't orbit any star. Instead, they float freely through the galaxy, completely untethered. Some of these space loners are about the size of Jupiter, the largest planet in our solar system, while others might be as small as Earth or even smaller. They don't shine like stars, and they don't have solar days or nights. They just keep drifting endlessly in the dark. Astronomers believe that rogue planets could be more common than stars. That's right, there may be trillions of them drifting through the Milky Way alone. Think about it. While we gaze at stars lighting up the night sky, countless hidden worlds might be cruising through the cosmic shadows, completely unseen. Alright, time for some detective work. Rogue planets are super hard to spot because they don't reflect light from a nearby star. They're like cosmic ninjas, stealthy, cold, and nearly invisible. So how do astronomers track them down? The most powerful tool we have is something called gravitational microlensing. Here's how it works. When a rogue planet passes in front of a distant star, the planet's gravity bends the light from that star, causing it to brighten temporarily. It's like nature's own magnifying glass. That little flicker of light gives away the rogue planet's presence. Space telescopes like Kepler, OGLE, and soon the Nancy Grace Roman Space Telescope are key players in this game. They monitor millions of stars for tiny, temporary changes in brightness. If they catch a dip or a spike that doesn't match anything orbiting a known star, they've likely spotted a rogue planet. Light that briefly turns on in a pitch-black forest. But with better tech and new missions, we're getting closer to building a cosmic map of these wandering worlds. What are rogue planets like? So what's it like on a rogue planet? Well, without a star, things get really chilly. We're talking temperatures near absolute zero. That's minus 273.15 Celsius, the coldest possible temperature in the universe. But that doesn't mean they're just frozen rocks. Some rogue planets could be gas giants with thick atmospheres of hydrogen and helium. Those atmospheres might trap heat from the planet's formation or from radioactive materials in the core, keeping the interior surprisingly warm. Some might even have liquid water hidden under icy crusts. That's right, even in the cold, dark void of space, oceans might exist beneath the surface. Think of them like supersized versions of Europa or Enceladus. Moons in our own solar system believed to have subsurface oceans. And if water exists, the big question is, could life exist too? It's not out of the question. If a rogue planet has the right chemistry and warmth inside, it could be a cozy little hideout for microbial life. Nature has a way of surprising us. Where did they come from? So where do these space nomads come from? There are two main theories. One, ejected from planetary systems. Many rogue planets might have started out just like Earth, forming in a young star's orbit. But in chaotic early solar systems, giant planets sometimes collide, clash, or come too close to each other. If the gravitational balance gets upset, one unlucky planet might get flung out of the system entirely, banished. That's how a planet can become a rogue. 2. Formed alone. Some may have formed out in the galaxy without ever being part of a solar system. If a dense cloud of gas collapses but doesn't gather enough mass to ignite as a star, it could form a planetary mass object instead, a rogue from birth. In either case, their stories are full of cosmic drama, gravitational brawls, lonely births, and eternal wandering. Space is intense, folks. Why do they matter? Now you might be thinking, cool story, Croc, but why should I care about some cold, lonely planets? Great question. Studying rogue planets teaches us how planets form, how solar systems evolve, and how gravity shapes everything from stars to galaxies. They help us understand the violent, messy nature of planet formation, something our peaceful solar system doesn't always show. They also expand our view of where life might exist. If life can survive on a world with no sun, then the possibilities for extraterrestrial life just got way bigger. It's not just stars with habitable zones. We might need to look in the dark too. And finally, they push our technology forward. Finding these sneaky wanderers forces scientists to invent new methods and tools. Every rogue planet we find is like a new level unlocked in the game of cosmic exploration. So there you have it, cosmic explorers, rogue planets, mysterious, wandering, and possibly more common than stars. They're the loners of the universe, but full of secrets and surprises. Keep those eyes on the stars and the shadows between them, because that's where the weirdest wonders hide. Until next time, this is Cosmo Croc, drifting through the dark, chomping on curiosity and bringing you the untamed tales of the cosmos, one lonely planet at a time.